You gave me Samuel? What's this? Never mind. You got any more on your paper?
Yeah, number 24, it's a series of questions about the same line graph. And it's on page 539. The line graph is given to you. It represents the trend depicted by the percent of men and women 65 years old in the labor force from 1920 all the way up to 2000. It's interesting because the women's line, the red line, is fairly constant for 80 years. Men's is not. Drops dramatically from 1920 to 1980. Okay, number 24 says, what was the difference in the percent of men and percent of women over 65 in the labor force in the year 2000? Now, this is just a matter of getting some data off this line graph and doing a simple calculation with the data. So this is number 24. So you go to the graph itself, and you find in the year 2000, 18.6 is the percentage for men. And for the women, it's 10. So you just do a subtraction. 8.6 would be the difference between the two. That's part of a whole series of questions, but that's the answer to that particular one. Any other questions on the homework? 26. What was the overall trend in the percent of men over 65 in the labor force for the years shown in the graph? Well, it definitely decreases, but then it levels off from about 1980 to 2000. It looks like it's pretty much level. So to describe it, I would say decreases from 1920 to 1980, and then levels.
Well, it's kind of similar to 25, and 25 I thought we could average it.
What was the overall trend in the percent of women over 65 in the labor force for the years shown in the graph? Did you talk about 25 here? That's
Yeah.
a group?
So like
Okay.
50%.
Basically, it stays constant. And, I mean, it does rise a little bit and then goes back down again, but it's a very constant rate.
So don't overthink it.
I'm sorry?
So don't overthink it. You're doing math problems. Percent.
Well, this is a descriptive one. They just want you to describe it.
23.
23. It's the same thing. You're just getting two numbers from the graph and subtracting them. It's for 1920. The men are 55.6%. This is 2000. This is 1920. 55.6%, and the women are listed on the graph as 7.2%. So you subtract. .4% would be the difference. So this is just about reading numbers off graphs, that's all. Very simple. Anything else?
21A.
21A. Okay, we've got, this is the little icons kind of stuff. This has to do with books. Figure displays the annual sales of books for 3 major companies. Now this was quite a few years ago. The data is not up to date here. So it says Barnes & Noble / B. Dalton. It tells you in the little legend there that each one of those icons is worth $1 billion in sales. So 1, 2, 3, 4 billion, and then about half of the next one. It's about 4.5 billion for Barnes & Noble, and so forth. Okay, it says estimate the sales for the company with the greatest annual sales. That would be the Barnes & Noble. That's the highest one, so that's 4.5. And the total sales, you would simply take the other two. For example, Borders is about 3.5 billion, and so is Amazon. Add all that up, 4.5, 3.5, another 3.5, you add it up. It comes out to be 11.5 billion in sales. So a lot of people think everything is going digital. Not so much. People are still reading books. Anything else?
27.
27. Use the graph to predict the number of men 65 in the labor force, over 65 in the labor force in the year 2020. Answers will vary. Basically, what you do is this. I'm just going to sketch it up here. I'm not going to do an accurate graph, just to show you how you do it. Okay, so here we are. Let's say this is 2000 over here. That's the last actual data point we have for the men and the women. And this is measured. The men are at about 18.6. It's these numbers right here. And the women are below that. They're at 10. So it may be around like this, something like that. And these are percentages of people over 65 in the force. Okay, if you're trying to predict for 2020, let's put 2020 here. What you do is you take the line for the men or the women and simply extend it according to the last section. For example, 1980 is 19.3 for the men and 8.2 for the women. So it'll be a little bit above here. Let's say 1980 is right here. Be a little bit above where it is now, and this will be a little bit below where it is now. And that part of the graph actually is filled in. In other words, they put the line in there between those two dates, between 1980 and 2000. Now they're asking you to go out over here to this one. And the way you do that is simply extend the line that's most recent. So here you have...
So you wouldn't subtract the 18.6 from 19.3?
No, you're just concerned with the men. You're not concerned with the comparison. So you simply take that line for the men and go like that. And when you get to 2000, you put a dot there. If you wanted to do it for the women, you could too, but they asked about the men. So you say, well, what is that on the vertical axis? It turns out mine says it's about 18%. It drops about 0.6%. So it comes down just a little bit to about 18. That's what that number is. That's used for prediction. Makes a lot of difference to stores and companies and so forth. You want to predict what your sales will be and things of that nature. Any others? Okay, let's go on to section 9.2. Now, the data here, let's say this graph right here, we had data from 1920 to 2000, which means we had data points, two sets of data points actually, for 5 years. 5 years on the horizontal axis and the data points for both the men and the women. Okay, that's not considered a large amount of data. That's a fairly small amount. Actually, there's only 10 points there. 2 types of people, 5 years, 10 points. That's not a big deal. And most people have the ability to look at something like that and not fall over, you know, maybe even get some things out of it, understand what's going on and so forth. But it's true in statistics that very often you're collecting data that has an awful lot of input. And, you know, I mean, for example, there's an example we're going to start out with right now about the ages of the presidents when they were first inaugurated. And they have 42 presidents. Okay, well, their age range is quite big. And 42 points, you plot 42 points on a graph and people are going to laugh at you. You say, what are you doing? Nobody wants to figure out what 42 points are doing. So what you have to do is what's called massaging. You massage the data before you actually plot it. And this creates something called a frequency distribution. It's very similar to a bar graph. In fact, it is a form of bar graph when you draw it. But right now, we're going to do just the table for it, called the frequency distribution. And this is a special form of bar graph for large amounts of data. And that data is sectioned off into what's called class intervals. And the actual problem we're working on now is on page 541. It opens up with it. Right at the very top, there's your 42 entries. The age of the president at inauguration. Okay, 42 different entries. And the way you do this, you say, well, that's too much. Presenting that much data is going to turn people off. It's going to confuse them. They won't look at the graph and so forth. So I've got to get it to look nice. I've got to get it down to something like maybe 10 plots, 10 points, or something between 5 and 10 would be very nice. And people have patience for that. But more than that, no. So what we do is this. We say, okay, there's quite a range of ages here. Let's actually take a look at the raw data. It's sitting there. Raw data is just numbers. There it is. Okay? Look at the raw data and you say, well, okay, where are the lows and where are the highs? Here's a 69. And there's some 40s. There's a 49. There's a 46. You know, we're going from, there's a couple 46s as a matter of fact. Where's Kennedy? Kennedy was 43. There he is. Okay. Kennedy, I'm sure, was the lowest.
Yeah.
And
How old is Barack? Obama.
Obama was what?
How old is he?
How old is he?
Yeah.
Oh, I think he was in his 50s when he was inaugurated.
Oh,
He's
wow.
46.
So he's late 50s.
I think he's 46.
46?
Yeah.
Okay. He's not in this. He's not included in this because this is too old. I think Reagan was the oldest. I think he was 69. Okay. So we got to cover a range between, let's say, low 40s and almost to 70. Okay? So what do we do there? Well, I mean, you say, I can't have more class intervals than maybe 5 to 10, because people will stop looking at it if I put too much data up there. So what I want to do is create class intervals, which are sections of data, and they have several requirements. Number one, each section is equal size. Number two, there is no overlap. data. In other words, you can't have a piece of data that fits into two class intervals. It's got to fit into one and only one class interval, no overlap. And we need somewhere between, let's say, 5 to 10 class intervals. So if you take something like 70 and subtract 40, you get 30 years you've got to somehow present. What they did here is they decided to do 1, 2, 3, 4, 5, 6 class intervals. And those 6 class intervals are indicated right here on the first table that you see here. Those 6 class intervals, let's read what kind of numbers they have in them. The first one is 40 to 44. Now, how many years is that? How many years does that cover?
4.
40, 41, 42, 43, 44, 5. Right? That's what you said. You said 5, didn't you?
4.
No, you said 5. That's a 5-year class interval. Okay? All right. So if you have 6 of those, and all of them are equal size now. Okay? They're all 5-year intervals, and there are 6. That covers 5 times 6, or 30 years. That'll do it. So that's what they chose to do for their class intervals. And they look like that: 40 to 44, 45 to
49.
49, that's right, you gotta be careful. This is also 5 years, okay? And notice no overlap. This can't say 45 up there, this can't say 44 down there. No overlap. It's gotta be clear which interval it goes in. Okay, and then we get 50 to 54 and so forth. Pardon?
You looked happy writing, so I was just gonna have you put 70.
No, it's not 70. Luckily, there's no president is 70, so this works. Okay, so first of all, you establish your class intervals, and they've got to obey these rules. You've got 6 of them there, that fits in the space between 5 and 10, no overlapping, each one equal size. Okay, and then what you do is show how many of the presidents are in a particular class interval. Now, that's not giving everyone very precise data, okay? It's not plotting 42 different points to show you what the ages of the presidents were. And there may be some overlapping in the presidential ages, that's for sure. But still, it's not giving you very precise information about individual ages. It's throwing them into classes and then presenting the information in these 6 classes. So it's reducing the precision of the data, but it's making it a lot more readable and much more. I think more people would say, okay, I'd rather have that than have 42 points scattered all over the place. So you set it up this way. With frequency distributions, you create a table. The first column of the table is what you see right there. And then you start filling in the rest of the columns. The tally and the number, or the frequency as it's sometimes called. This is the class intervals. This is called tally, and all that means is tally marks. You just put the little things here. And this is the frequency, but it's in regular numbers. So we put our rows in and get started counting. And this is, yes, tedious and boring and so forth. And that's the only way to go through it. Luckily, we can skip that and just write in the answer because it's right below there. Only one person between 40 and 44, okay, and that would be Kennedy. Okay, 45 to 49. Now, traditionally, when you reach 5 of these tally marks, the 5th one is done like that. And that simply creates groups of 5, so it's easy to read when you're going over here. But there's 2 more people there, so there's actually a total of 7 in this class interval, and so forth. This is the big one. So there's 10, 13 in the 50 to 55 range. And I think that's where, you see, Obama was in his 46, was he, when he started? So now we're almost 8 years later, 7 years later. So he's 53, he's up in this now. Okay, 55 to 59 has 11. 60 to 64 has 6, 7, and 3 in 65 to 69. Now, when you, frequency simply means write it in regular numbers. This is 1, this is 7, this is 13, this is, did I get this right, 55 to 59? No, there's 11. There's 1, oh, I see. There's 11 there, yeah. And this is 7 here. And this is 3. Okay, now that sets up everything you need to do a graph. And the graph for a frequency distribution is given a specific name. It's called a histogram, but it is still a bar graph. So let's just go ahead and do this. Let's see what it looks like. So we put up our axes, our vertical axis. Now, what do you think is going to be on the vertical axis?
Class.
No, they put the class intervals on the horizontal axis. And that is always done. The tradition is put the class intervals in.
Age
On the
group.
vertical axis will be
Age group?
the frequency. Yeah. That's why it's called a frequency distribution. You're looking at what classes or what sections these frequencies fall into. Okay, so you just put them down here. Let's say this is 40 to 49 from here to here. And so forth. 40 to 45, 44, I'm sorry. And over here, we'll put a different one. This will be 45 to 49. This will be 50 to 54, and so forth. Yeah, you guys extended just a little bit. Okay, so this is a very low one, 1. And look where they're going. They're going up to 13 and so forth. So the end result of doing this is a few pages further on. If you turn over to page 543, you can see the graph actually done in your book. And it looks like a regular bar graph. It has all the requirements of a regular bar graph. The bars are equally spaced, and the width of each bar is the same. And for the 50 to 54, you get the 13 people. That's the highest bar. The 1 just barely registers down there, but that's considered a good-looking bar graph. In other words, your small one can be seen, but you know, the bars actually go up to almost the top of the bar, the graph, and that's considered to be aesthetically attractive. So people like to see their data like this. So they're getting less information, but they're getting it in a perhaps an easier way to read and comprehend. That's frequency distributions and histograms. Now, this last method of graphing information and presenting information actually is fairly common, and people like it an awful lot. It's very visual. It's called a circle graph or a pie chart. And if you remember the circles we started with a long time ago, which were thought to be pizzas, you know, because of the time of our class. Everyone pays attention when you say pizza. The pizzas had a certain meaning to them. The more familiar name for this is pie chart. And what you're doing is creating sectors. Now, sectors are like slices of pie. Sectors, which represent a fraction of the whole. And that's exactly what we did with pizzas. When we had a circle like that, we started dividing it up into some number of total pieces. Now, we made our pieces equal size. Pie charts are not always equal size. But we started out with something like this. We have maybe a 6-piece one. And we say, okay, there's 6 pieces in the whole, and we translated that whole idea right immediately into a fraction. The 6 would go in the denominator of the fraction, and let's say we had actually 2 pieces left. We have 2 out of 6, or we have what we call 1/3 of a pi. Now, that 1/3 can be represented in terms of percentages, can be represented as fractions, can be represented as a decimal. Lots of things can happen with that. But the whole idea of the circle with sectors or pieces of pie representing certain fractions of the whole thing is very useful. If you go onto the computer, use, let's say, Excel, Microsoft's program which does data analysis, it's called a spreadsheet. You put your data in. You know, you put, let's say, 42 inaugural ages for the presidents. And then if you want to, you can go up into a menu and say, make me a pie chart for that. And it'll say, okay, what class intervals do you want? You tell it the class intervals. And it will present it as a pie chart. And it does it automatically. It graphs it for you. It's very nice. It'll even use different colors if you've got a color printer and print it out like that. One button is all you need for that. Very nice. Well, it's not always that way. In class, we'll have to draw our own. Okay, example 1 says the grade distribution for a math test is shown in the circle graph. And there it is. Now, what's happened to this circle is that it's tilted on edge, so it doesn't look like a circle anymore. It looks like an oval. That's okay. It's still a circle. And you find out that A's are the blue ones, 6 of those. B's, nice red ones, 10. C's, sort of a gray, 12. D's are kind of an orange, 3. And then there's this pink slice over there, 1F. Okay? So notice the pieces of the pie are different sizes. And they ask you questions like how many grades are B. So you look up there and say, oh, B, comma, 10, obviously 10. But then they say, how many times more C's are there than D's? Well, there are 12 C's and there are 3 D's. So they're saying, how many times more C's are there than D's? Well, what would you have to do to multiply 3 to get 12? 4. So there's 4 times as many C's as D's. And then the last question says, what percent of the grades were A's? Let's take a look at that. We know that the A's have 6, okay? We know that the total number of students in this class, or total number of people taking the test anyway, is a sum. And it looks like this: 6, 10, 12, 3, and 1. So if you add all those up, that's 16 and 12 is going to be 28, and 3 is 31, and 1 is 32. Huh? So there's 32 people in the class. 6/32 of them represents the number of people, or it represents the fraction of the people who got A's. Okay, what do we do with that? Well, one thing we can do is convert it into a percent, because that's what they ask us for. Take 32, divide it into 6. Okay, 32 into 60, that's 1, and so forth. So you do the usual stuff. Bring down 32 into 280. 7 maybe? 6? Okay. 6 times 2 is 12. 18, 19.
Say one more.
It'll be more than that. Yeah.
8.
So what would you say there? Well, it's not 10 because that would give you 320. So let's say, let's do 7 and see what happens. 14, 21, 22. No, I think it's even bigger than that, huh? 18. All right. 25. Yeah, there we go. Okay. And that's 2. And then we bring down 240 to be a little bit less than that. This would be a 7 over here. Okay, so we're going to say this is approximately 0.1 of 9. We'll round it to that position. And that's a decimal now. We've converted the fraction into a decimal, but they want a percent. And so you take the 0.19, multiply it by 100 to get 19, and then you put a percent sign on it. So 19% of the class got A's. And very often, instead of writing a pie chart in terms of numbers, like 6 and 10 and 12 and so forth, they'll actually write it in terms of percentages. They will do the conversion to percentage and put it in the pie chart itself. So you can see both types, numbers and percents in pie charts. Let's go on to actually constructing one of these things. And this requires what's called a protractor. And a protractor, we talked about those before when we were doing the angles thing. It's a way of measuring angles. Your book even has a picture of one in there. Looks something like this. This is where you center it on the vertex of the angle. And then it's got these scales that go like this. It goes from 0 to 180. This is 90 up here and so forth. I have a very old, this is a relic. And I got it out of a display case in the other building, and they made me swear I would return it. So, this is a gravity protractor. And you say, well, what does that do? It uses gravity. Very clever, huh? Yeah. So what you do is you line this up with a certain line, you go down there, oh, that's a 25-degree angle. It just uses gravity to tell you what the answer is. Very nice. So we're going to use that. All right, so we're going to start out with this problem. It's a problem that's very down to earth here. A teacher earns a monthly salary of $2,400 after taxes. Not on this peninsula, they don't. The monthly budget is broken down. So you have a table here, and the table has the various categories, rent, utilities, car, and so forth, and then the amount she spends on those amounts, those different utilities and categories. This is page 549. Okay, so we want to create a pie chart for her, and on the next page you see the table that actually does that. So I'm going to put part of that up here so you can see what's going on. And this takes a while, you just have to be patient with it. This column has the budget item. This has the monthly cost. This is the percent that represents, the percent of the total budget. And this represents the number of degrees in the pie chart, which is a circle. And they have 1, 2, 3, 4, 5, 6 here. So you have things like rent, utilities, car, groceries, savings, and other. Here are the amounts they give us: $840, $210 for utilities, $510 for car. That's almost as much as the rent. Huh. $360 for groceries. She doesn't eat much. Savings $300 and $180 for other. You know what other is, right? Everyone knows that. You play, right? Entertainment, something. Who knows? Okay. Now we have to go to percents of budget, and this is important. Let's start with Bertie this stuff. Let's get a calculator out. Okay, the total budget, did they give us that yet? 2,400. So all of this totals up to 2,400. Okay, that's the monthly pay after taxes. So what we want to do here is take that particular item, rent, make a fraction out of it, convert it into a decimal, and then write it as a percent. All of that's got to go in here. So the fraction would look like this, 840 divided by 2,400. And put that into the calculator. And I get 0.35. Okay, converting that to percent multiplied by 100 with the decimal point over, that's 35%. And so forth. I'll do a few more. This will be 210 divided by 2,400. And that comes out to be 0.0875. Again, multiplying by 100, that would give us 8.75%. And one more, 510. That's 0.2125, which gives you 21.25%. Okay, now the important thing is how do you get those into slices of pie? Well, the entire pie is 360 degrees. So we can say, what is, going back to our percent area, what is 35% of 360 degrees? Okay, well, for that we go back, change it to 0.35, multiply by 360, and that should give us the number we're looking for. So that's a 0.35 times the 360, and that gives us 126. Now that's the number of degrees in the circle that represents her rent payment. That's how wide you have to make that slice of pie, 126 degrees. Okay, this one is going to be 0.0875, going back to the decimal here. 0.0875 multiplied again by 360. This is 31.5 degrees. This one is 0.2125 multiplied by 360. 76.5 degrees. So when you start doing your circle, you have to make the degrees that size. Okay, so we'll take that as the center, and we'll draw a line like this to start our sector. Now, what we want to do is, first of all, put a 126-degree line on there. I'm going to use this upside down for just a minute. Okay, this goes to 90. This is 90. This is 100. 126 will be right there. So that's the biggest chunk, as a matter of fact, is rent. So this is labeled rent. And if you want to, you can put the size of degrees, or you could put the 35%, or whatever you want to. You could also put the 840 in there. Gives more information to the reader. Okay, now the 31.5 degrees, which represents utilities, what we're going to have to do there is take the protractor and line it up with the far side of this angle, and then go over 31.5 degrees more, which is going to be 10, 20, 31.5 will be right around there. So that's going to be the utilities. And the next one is 76.5 degrees, which represents the car. So again, we start at this one and go over 76.5, 10, 20, 30, 40, 50, 60, 76.5 will be right around there. Now this is what Excel does for you automatically.
Yeah, of course.
And the whole thing gets filled in. Now, of course, the whole thing's got to add up to 360, so you've got all the pieces fit together into the one sort of thing. Okay, that is a pie chart. It takes a while to make these things, but people really like them a lot. Okay, we're 9.2 and 9.3 here.